So all we're going to do today is practice these probability tree questions. Now, sometimes they give you the probability tree to fill in, but however, a lot of the time, especially nowadays in the GCSE exams, they will not tell you to draw a probability tree diagram. You've got to just kind of read the question and see you've got kind of two events happening, and you have to know that a probability tree is going to help you out, at least in terms of the interpretation. So let's have a look at this question. So Natalie has 8 socks in a drawer, 5 of the socks are black, 3 of the socks are white. Natalie takes out a sock at random, writes down its colour and puts it back in the drawer. What a bizarre life she leads. So then Natalie takes out a second sock at random and writes down its colour. So we've got two things happening first of all. So this is her first pick. Alright, and the options are either, that first pick is either black or it's white. Then she's going to do a second pick. So again, if she's picked a black the first time, well, she can still pick a black or a white for the second one. And similarly, if she picks white first, I've still got 2 options for the second one. It's either going to be black or white. The probability that she picks a black out is 5 out of 8, because there are 5 black socks in the 8 socks in total. And then obviously that is 3 out of 8. If I didn't have the number here, I could have just worked out the difference between that and 1, obviously. I put it back in, so again for that second pick, I've kind of started again. It's 5 out of 8. I'm going to pick a black sock out, and 3 out of 8 is white, and same down here. We are going to look at some in future which are slightly different at that point. So at this point, because I've not got many branches, I could work out all of these probabilities. And I'm going to do that now just so I can remind you how these work. So the probability of me taking a black sock to begin with and then another black sock. So when we move along these branches, we multiply the probabilities. So I'm going to do 5 over 8 times 5 over 8. And I get 25 over 64. Even if that could simplify, I'm not going to, and I'll tell you why in a bit. Okay, so the next option is I pick a black out to begin with and then a white one. So 5 over 8 times 3 over 8 is 15 over 64. A white followed by a black would be 15 over 64. And finally, a white followed by a white would be 9 over 64. And if I added these 4 together, the numerator, it should give me 1, because obviously one of these has got to happen. They are exhaustive events. So the question, work out the probability that she picks out at least 1 black sock. So the way I like to use these tree diagrams is to tell the story of what's going on. So I want to know the probability she picks out at least 1 black sock. Well, the options is she picked black followed by black. So that gives me at least 1 black sock there. I could have picked a black and then a white. So I need that probability because that's given me at least 1 black sock. This one gives me at least 1 black sock as well, a white followed by a black, so I need that one, but this one down the bottom doesn't, a white followed by a white. I need at least 1 black sock, and that does not result in that. When I'm moving along branches, I multiply is a nice trick, and if I'm moving between branches, so I know that for this to be true, for us to pick out at least 1 black sock, either this has happened, or this has happened, or this has happened. And to get the probability when it's or, we add them together. So if I add those together, I get 55 over 64. And that's my answer. So just make sure you're reading the question. A lot of people would say, work out the probability she picks out at least 1 black sock. They would go black and then white, followed by white and then black, and they'd forget this top branch here. But the question is, work out the probability she picks out at least 1 black sock. Picks out 2 socks, that still counts. Right, another. So in a small bus, 1 bus arrives a day. The probability of rain in the village is 0.3. If it rains, the probability of a bus being late is 0.4. If it does not rain, the probability of a bus being late is 0.18. Work out the number of days the bus will be late over a period of 80 days. Right, so let's draw our probability tree. So we've got some independent events going on. So let's first we'll look at weather. So it either rains or no rain. Okay, and the probability of raining is 0.3. Therefore, the probability of it not raining is 0.7. So that's the rain dealt with. The next one is the lateness. All right, so if it rains, even at that point, it's either going to be late or on time. And same if it doesn't rain, it's either late or on time. Then we need to make sure we're putting the right probabilities in. If it rains, so that's along here, if it rains, the probability of it being late is 0.4. So the probability if it rains and it's on time is 0.6. The probability it doesn't rain and is late is 0.15. So it's either if it doesn't rain, it's either late or on time. So therefore that was 0.85. Okay, if you just notice again to reminder that when we've got kind of a set of branches like this, they have to add to 1. They have to add to 1. Okay, so the pairs of branches, or even if you had 3, the 3 there would have to maybe you have tree diagrams like this. These 3 probabilities here again, because one of those events has to happen, the probabilities have to add to 1. Okay, work out the number of days the bus will be late over a period of 80 days. So we need to work out, first of all, the probability of it being late. Well, the options are it rains and it's late, or it doesn't rain and it's late. So let's work out these 2 probabilities. So 0.3 times 0.4, 0.12. 0.7 times 0.15, 0.105. So if it's arrived late, it's either this or this. So let's add those together, and I get, so the probability of a bus being late on any given day is 0.225. I want the number of days the bus is going to be late. Well, this, if you like, is 0.225. You may remember like kind of the formula for expectation. However, don't forget another way to think about this is 22.5%. So it's going to be late 22.5% of the time. So I just need to find, so if I've got 80 days, it's going to be, we're expecting it to be late 22.5% of the time. So to just work out that expectation, I can just do, well, expectation, and you have this somewhere from previous work. Expectation, if I'm talking about probability, it's the number of events multiplied by the probability of it happening. So, for example, if flipping a coin, the probability of me getting a head is 0.5. So if I wanted to know how many heads I would expect if I flipped that coin 70 times, well, I would do 70 times 0.5, and I'd expect 35 heads to come up. I'm probably not going to get 35, but that's the expectation. Here, so the number of events are at 80 days. The probability of it being late is 0.225. So I would expect that it to be late 18 times. Okay. So now have a go at the Dr. Frost questions. Some of them, they've got the trees there ready for you. However, some of them you're going to have to draw the probability trees in your book to be able to answer those questions. And let me know if you need any help by logging onto the Google Meet.